If ancient mysteries, hidden chambers, and discoveries that challenge everything we thought we knew fascinate you, make sure to subscribe and turn on notifications. Because today's story begins inside the most studied monument on Earth, and with a question that modern technology still can't fully answer. For more than 4,500 years, the Great Pyramid of Giza has stood silently above the Egyptian desert, surviving empires, invasions, earthquakes, and countless generations of explorers. It has been measured with lasers, photographed from space, scanned with satellites, and examined using technologies its builders could never have imagined. Most historians believed there was very little left to discover. Every major chamber had been mapped, every passage carefully documented, every stone analyzed in extraordinary detail, or so they thought. Because in recent years, scientists began feeding decades of internal scan data into artificial intelligence systems designed to recognize patterns too subtle for the human eye. Instead of searching for hidden treasure or secret tunnels, the AI was asked to answer a much simpler question. Did previous generations overlook anything hidden inside the enormous amount of information they had already collected? At first, researchers expected nothing unusual. The scans came from multiple independent projects using different technologies over several decades. Ground-penetrating radar, moon particle imaging, laser measurements, thermal observations, and structural surveys had already produced millions of individual data points. Human experts had spent years studying them. Surely any major discovery would already have been noticed. But artificial intelligence approaches problems differently. It doesn't become tired. It doesn't ignore tiny inconsistencies because they appear insignificant. Instead, it compares every measurement against every other measurement simultaneously, searching for relationships that no single researcher could realistically identify. After several days of processing, the system highlighted something unexpected. Deep inside the pyramid, beyond the well-known Grand Gallery, several independent datasets appeared to contain the same subtle anomaly. Individually, none of them looked remarkable. A slightly unusual density reading here, a faint thermal variation there, a tiny deviation in particle measurements recorded years apart. Each had previously been dismissed as normal statistical variation. Yet when combined, they formed a pattern that refused to disappear. The AI repeatedly identified the same location as statistically different from the surrounding structure. Researchers initially assumed the software had made a mistake. Complex machine learning models sometimes detect meaningless correlations hidden within enormous data sets. To test the result, they deliberately removed one entire scanning project from the analysis. The anomaly remained. They removed another. Still there. Different algorithms reached nearly identical conclusions despite working independently. That immediately caught the attention of structural engineers and Egyptologists alike. No one claimed they had found a hidden chamber. Not yet. But something inside the data clearly demanded a closer look. The location itself made the mystery even more intriguing. It wasn't inside one of the famous rooms visited by tourists every year. It appeared to lie behind massive stone blocks, in an area that has never been physically explored. According to current understanding, there shouldn't be anything particularly unusual there at all. Yet the AI kept assigning the region an exceptionally high probability of containing an unexplained structural feature. Some researchers suggested the anomaly could simply represent a previously unknown stress relief cavity created during construction. Others believed it might indicate variations in the limestone itself. Both explanations sounded reasonable, until additional simulations introduced another surprising detail. The surrounding stone arrangement appeared more symmetrical than expected for a naturally occurring construction irregularity. Ancient Egyptian builders were astonishingly precise, but they also adapted constantly during construction. Tiny imperfections are common throughout the pyramid. This anomaly, however, appeared strangely consistent across multiple independent measurements. The more scientists examined the data, the less certain they became about its origin. Then another team compared the AI's findings with thermal imaging collected years earlier during a completely unrelated research project. During brief periods around sunrise and sunset, certain sections of the pyramid's outer surface warmed and cooled at slightly different rates than neighboring blocks. The differences were extremely small, far too subtle for anyone standing nearby to notice, but they matched the same internal region highlighted by the artificial intelligence. Once again, the evidence wasn't proof of a hidden chamber, but independent technologies were beginning to point toward exactly the same location. That coincidence was becoming increasingly difficult to ignore. Discussions quickly spread across the international research community. Some experts urged caution, reminding everyone that extraordinary claims require extraordinary evidence. Others argued that if multiple unrelated methods repeatedly identified the same anomaly, it deserved serious investigation regardless of what the final explanation might be. One veteran engineer summarized the situation perfectly. The AI isn't telling us what's inside the pyramid. It's telling us where we should start asking better questions. That statement changed everything. Instead of treating artificial intelligence as a machine capable of providing answers, researchers began using it as a tool for discovering questions nobody had thought to ask before. New simulations were ordered. Archive scans were reprocessed using improved software. Additional structural models were created to determine whether any known architectural feature could explain the anomaly naturally. Days turned into weeks. Every new analysis seemed to narrow the range of possible explanations, yet none completely accounted for all the available evidence. Some scientists quietly admitted that if the pattern continued appearing in future studies, they might eventually have to consider possibilities that had previously seemed unlikely. Not impossible, but unlikely. And then one final comparison produced a result that nobody inside the research group expected. When the AI overlaid the internal anomaly with stress distribution models of the entire pyramid, the mysterious region appeared to occupy one of the most structurally significant positions in the entire monument, as though its placement had been carefully calculated from the very beginning. Whether that meant hidden engineering, an undiscovered architectural feature, or something far more ordinary remained completely unknown. But one thing had become clear. The Great Pyramid might still be hiding secrets, not because nobody had looked before, but because until now, no one had been able to see the data the way artificial intelligence could. And what the next stage of analysis revealed would leave even the most skeptical researchers struggling to explain it. The research team now faced a difficult decision. They had enough evidence to justify a new investigation, but not enough to claim they had discovered anything hidden inside the Great Pyramid. In archaeology, making extraordinary announcements without overwhelming proof can destroy decades of credibility. Every scientist involved understood that the world would immediately begin talking about secret chambers, lost treasures, or forgotten burial rooms. That was exactly what they wanted to avoid. Instead, they focused on one simple question. Could every anomaly detected by the AI be explained using known engineering principles? Structural engineers built increasingly detailed digital models of the pyramid, recreating millions of limestone blocks, one by one. They simulated gravity, earthquakes, temperature changes, and thousands of years of weathering. If the unusual readings were caused by natural settling or hidden cracks, the computer should reproduce them. But the simulations kept producing an unexpected result. The mysterious region remained unusually stable compared to the surrounding structure. Rather than appearing as a weak point, it behaved almost like a carefully designed feature, distributing weight through the pyramid. That immediately caught the attention of engineers. Ancient Egyptian builders had an extraordinary understanding of stone construction. But could they really have designed internal load relief systems far more sophisticated than previously believed? Some researchers argued yes. Others urged caution, reminding the team that computer models are only as accurate as the information entered into them. To reduce uncertainty, archived muon scan data collected years earlier was processed again using the newest AI algorithms. Muons are tiny particles created when cosmic rays strike Earth's atmosphere. They constantly pass through solid rock, allowing scientists to estimate internal density without drilling into ancient structures. Previous studies had already revealed the famous large void above the Grand Gallery, proving that muon imaging could detect hidden spaces inside massive monuments. This time, however, the AI wasn't searching for empty rooms alone. It examined subtle variations in particle flow that human analysts had previously ignored. Once again, the same location appeared. Not as a clearly defined chamber, but as a region whose internal density behaved differently from the surrounding limestone. The difference was incredibly small, almost invisible within the raw data. Yet when millions of measurements were combined, the statistical confidence became increasingly difficult to dismiss. The probability that several independent technologies would repeatedly highlight exactly the same location by pure coincidence seemed remarkably low. News of the ongoing analysis slowly spread through academic circles. Some Egyptologists welcomed the new methods, believing artificial intelligence could become one of archaeology's most powerful tools. Others remained skeptical, warning that machine learning systems sometimes identify patterns that have no real world meaning. Healthy skepticism, they argued, is essential. Whenever computers begin making discoveries humans cannot easily verify. Meanwhile, another team looked beyond the pyramid itself. They compared the anomaly with architectural layouts inside other Old Kingdom pyramids built during roughly the same period. Surprisingly, they noticed that several monuments contained internal spaces positioned in locations serving important structural purposes. None matched the Great Pyramid exactly, but the comparison suggested that hidden architectural features were not entirely unprecedented in ancient Egyptian engineering. If true, the mysterious region might represent an ingenious construction technique rather than a forgotten burial chamber. Even that possibility would dramatically reshape our understanding of how the pyramid was built. Then came another unexpected development. Engineers used AI to analyze microscopic temperature fluctuations measured across the pyramid's outer surface over multiple seasons. Instead of examining individual images, the software tracked tiny thermal changes occurring hour by hour throughout the year. Once again, the same internal region subtly influenced how nearby stone blocks gained and lost heat. The variations were far too small for human observers to notice, but the AI consistently linked them to the anomaly identified by radar, muon imaging, and structural modeling. Four completely different scientific approaches were now pointing toward the same location. None provided definitive proof of what existed there, but together they formed one of the strongest cases yet for conducting further non-invasive investigations. Importantly, no reputable research team concluded that the Great Pyramid contained alien technology, hidden treasure, or evidence of a lost civilization. Those sensational claims quickly spread across social media, but the actual scientists remained far more cautious. Their conclusion was both simpler and in many ways even more remarkable. Modern technology may still be uncovering engineering features inside the most famous monument on Earth that generations of researchers either overlooked or simply lack the tools to detect. If that proves true, it would demonstrate not that history was wrong, but that our ability to study history continues to evolve. Every new technological breakthrough gives us another opportunity to ask better questions about ancient achievements that still inspire wonder thousands of years later. Today, the Great Pyramid remains one of humanity's greatest engineering mysteries, not because we know nothing about it, but because every major scientific advance seems to reveal another layer we never realized was there. Artificial intelligence has not solved the pyramid. It has simply shown researchers that even after centuries of exploration, the world's most famous monument may still have stories hidden inside its stones. And in the next part, we'll examine one of the most controversial theories proposed after these AI analyses, why some researchers believe the pyramid's internal layout may have been designed with mathematical precision far beyond what anyone expected, and why that idea continues to divide experts around the world.